So now this is one part which we didn't complete. It's a small part. Okay. So now it's the last portion of that whatever fractions we were trying to cover. Okay. So now this. So let us assume Avinash has half acre of land, and he wants to sell 1/4 of it. So what is he trying to do? He's trying to sell 1/4 of half. So till now we were talking about what is 1/4, what is meant by 3/4, what is meant by 7/4, all those things. Now we are telling what is 1/4 of 1/2. Right? So if you see pictorially, if this is half acre, what will be 1/4 of this?
1/8.
Yeah, so this 1/4 of this means here the thing is you are dividing this into 4. So normally when you tell 1/4, actually you are dividing the whole circle or the whole pie. That pie can be your classroom, or if it is a census, it could be the whole population of the country or the world. If it is about cake, it can be the whole cake. Whatever is the object you are dividing, you divide that into 4. But here it is different. Here we are telling what is 1/4 of half. You understand? So that wording in English is important. So that is what does the trick here. What is 1/4 of half? So this half you divide into 4 pieces. So what is the value of each piece then?
1/8.
So that is 1/8, because this is actually you are dividing the whole piece, whole cake or whole property. The whole property you are dividing into 8 pieces. So the half property will get divided into 4 pieces. So this what is the value of this whole piece then? What is the value of 1/4 of 1 acre? So if you see that this 1/4 of half acre is actually 1/8, which is actually what you do in algebra, right? In algebra, when you tell 1/4 of 1/2, you just multiply this 4 and 2. That is actually because of this. You understand? So why when you multiply two fractions, why you are able to directly multiply is because of this. Because when you tell 1/4 of half, actually what you are doing is you are making the whole pie into 8 pieces. That is why this 4 into 2, 8 you are getting. Right? Get it? All of you?
Yes.
Okay. So now do this. What is 3/4 of half? You can mark it. Yeah. So you actually, so how he did 3/4 of half? How you get it? See, yesterday you remember 3/4 is 3 1/4, right? Remember 3/4 is 3 1/4. So if you get 3/4, you divide this into 4 pieces. What? The half acre you are dividing into 4 pieces, not the whole stuff. So that is the stuff you have to understand. So when you tell Shivananda wants to sell 3/4 of half acre. So that is the trick here. Yeah. So then what will happen? Each of this piece will become 1/8, 1/8, 1/8. So this 3 of it will become 3/8. You understand? So that is why when you multiply two fractions, you can multiply numerator to numerator, denominator to denominator. Do you get that?
Yes, sir.
I see.
Yeah. So that is why that is where from that arithmetic usage, like when you learn, you will learn, right? If you multiply fraction, you can multiply numerator, denominator. That is actually because of this. Now you visualize it. Why you are multiplying 4 into 2? That is because if you are dividing half or any fraction into some more one more fraction, actually you are increasing the denominator, increasing the division. And whatever is on the numerator 3, that many pieces you will get. Yeah, all of you? Okay, right. So we are not trying to find out 3 by 4 into 1 by 2. That all of you have seen, maybe learned in LP or UP. We are trying to see where from that operation is coming. Okay. Okay. Yeah. Okay. So now today we get into a new topic now. Okay. So that is what you call as decimal numbers, right? Okay. So just somebody tell what is decimal? What is meant by decimal number? What is meant by
Numbers
decimal?
with the base of 10.
Yeah, numbers which have the base of 10, right? That is what we call as decimal, right? So what are the other bases? You know,
The base
60,
of 60.
16,
16,
16, 60. So actually those sort of things are not being used today.
2,
2, but 2 is being used, right? The reasons for that actually Leon and all had covered in his session. Okay, so we are actually using only this 2 and 10 too. Okay, right. So now this you remember we talked about it in the previous class. And this is tens and this is hundreds. All of us know this, right? Now, what is this for? Value of this for?
4 by 10,
1 by
4 by
10. Yeah. 0?
100 raised to the minus power.
10 to the power of minus 2 or 1 by 100. And 7, 10 to the power of minus 3 by 1000. Right? So this is the system. So if it is a 60 base system, this 10 will be replaced by 60. If this is a 16 base system, 10 will be replaced by 16. So in a 16 base system, after decimal, first number is 1 by 16. Second one is 1 by 16 square. Third one is 1 by 16 cubed. In a binary system, the first one is 1 by 2. Next is 1 by 2 square. Next is 1 by 2 cube. Next is 1 by 2 raised to 4. Here also, first one is 2 raised to 0. Second is 2 raised to 1. Second is, then it is 2 raised to 2. Then is 2 raised to 3. Whether it is 60, 60, 10, all follow similar method. You get that? Yeah, so this is what we call as base 10. Now, when we get into binary, now you tell me what could be the value of this first one?
2,
No.
2,
So 0.
0. Okay. So what will be the place value of this? This place?
Tens.
ones,
Yeah, that is ones. That is 2 raised to 0 or ones. That is what you have to understand. If this is 10 base system, this is 10 raised to 0. If it is 2 base system, 2 raised to 0. 60 base system, 60 raised to 0 or 1. So this is ones in all number systems. What about this position?
2 raised to
Tens.
1,
Yeah, that is 2's. 2 square 4's. 8. 16. Now you calculate the value of this figure in decimal. This is binary.
31.
31. How did you get that, Adnan?
If you add all of them, it's 31, right?
Are you sure? Can you add all this? This is 0, this is 0, right?
Yes.
Yeah.
26.
Yeah.
25.
See now, so the point is how you do this. How you do this is, this is base 2. You add 0 into 2 raised to 0, that is 1. Plus 1 into 2, that is 2. Plus 0 into 4, that is 0. Plus 1 into 8, that is 8. Plus 1 into 16, that is 16. Isn't this how you are doing it in 10 ways? You are doing it in the 10 ways in the same way. Is it not?
Yes, sir.
See, this is exactly how you do it in the 10 base system. It is nothing new. What is, see, let us assume this is 0. What will be the value? 0 into 10. That is 0. So you are just multiplying. What is the value of this piece? 215. It is 5 into 1 plus 1 into 10 plus 2 into 100. Is it not? Is it not how you learned? Is it difficult? Is it not how you calculate the normal 10 base number? Actually, why you are not recollecting? You have made that skill, and now you have forgot the basis of it. It's 215. Actually, like in LP school, lower primary school, you have learned 215. So you have learned 200s, 110s, 5 ones, like that you have learned. Is it not? But now you have become so used to those numbers, so you are now just not recollecting the basis of it. So the basis of it, actually you do it that way. If this is 853, you multiply 8 into hundreds plus 5 into tens plus then 3 into ones. If there is a one number in thousand position, let us assume you multiply that with 1000. That is how you calculate. You have learned it in lower primary school. This is equal to 200 plus 10 plus 5. Now it is exactly same way here. You take each number and multiply it with its place value. So 0 into 1, 1 into 2, 0 into 4, 1 into 8, 1 into 16. Do you get this now? Yeah. Now you see, now you have to understand an important point here. Now you see, with 2 digits, what is the maximum number you can represent with 2 digits in binary? What is the biggest number you can represent?
3.
It is 3. Why? The best you can do is 1 and 1. Do all of you get it?
Yes, sir.
With 3 digits, what is the maximum biggest number you can represent?
7.
999.
Are you sure, Vinayak? If it is 3 digits, the best is 111. 4 plus 2 plus 1. 4 plus 2, 6 plus 1, 7. See, if this is 1, value is 4. If this is 0, value is 0. If this is 1, value is 2. If this is 0, this position value is 0. If this is 1, value is 60. If this is 0, value is 0. If this is 1, this is 32. If this is 1, this is 64. Do you all understand this?
Yes, sir.
So now you tell me, with 4 digits, what is the largest decimal number you can represent?
15.
Yeah, because 8 plus 4, 12, plus 12, 14, plus 1, 15. Yeah, now with n digits, what is the biggest decimal number you can represent? With 2, you told 3. With 3, you told 7. With 4, you told 15. Are there relationships between these numbers? 4 and 15, 3 and 7, 2 and 3.
2 raised to n.
2 raised to n. Okay. So if it is 4 digits, 2 raised to 4 is 16, right? You can represent only 15.
2 raised to n minus 1.
2 raised to n minus 1. That is brilliant. Do you all get this? See, if it is 3 digits, the biggest number you can represent in 3 digits is 4 plus 2, 6 plus 1, 7. 2 raised to 3 is 8. 8 you cannot represent. If you want to represent 8, you need the 4th digit. So you can represent 1 less than 8. That is 1 less than 2 cubed. With 4 digits, you can represent 8 plus 4 to 8. Maximum decimal number you can represent is 1, 1, 1, 1. If all are 1, then this is 8 plus 4, 12, plus 2, 14, plus 1, 15. 15 is 16 minus 1, right? 2 raised to 5, sorry, 2 raised to 4 minus 1. So if you represent 16, you need a 5th digit. If you need to represent 32, you can't manage with this 5. With this 5, the biggest number you can represent is 16 plus 8, 24, plus 4, 28, plus 2, 30, plus 1, 31. If you represent 32 with 5 digits, it is not possible. Do you all understand this?
Yes, sir.
Okay. So this is a very important concept in computing. Okay. Why this is a very important concept in computing?
Computers only know binary language.
That is one. What else?
So we can, with this method, we can convert binary numbers into.
That is there, but why this concept that the highest decimal number you can represent, you can manage is 2 raised to n minus 1.
To calculate large numbers, it is easier.
Yeah, so you see, if it is an 8-bit microprocessor, 8-bit processor, what is the largest number it can handle in one operation? It is 2 raised to 8 minus 1. It is 255. So the original first kind of microprocessor we had used to be 8-bit. Before that was even 4-bit. So 4-bit processors, the initial processors, maybe some 20, 30 years back, initial processor microcomputers used to be 4-bit. With 4-bit means the biggest decimal you can manage in one operation is 8 plus 4, 12, 12 plus 2, 14, plus 1, 15. So I remember when we used to do program using 4-bit microcomputer, if you have to do an operation called 2500 into 55, this 2500, you have to make it into small chunks, a multiplication of value less than 15 with 4-bit microcomputer. With 8-bit microprocessor, the largest number you can deal is 255. That is one of the reasons the processing power of old computers were lower. And then came 16-bit. I think 16-bit maybe some 2 decades old. You know what is like in the advertisements and all, do you see what is the number of bits of the processors which you deal nowadays in your computers, laptops, your mobiles? Yeah, 32 or 64, like Sam has mentioned. So most of the stuff are 64-bit. 64-bit, it increases the capacity tremendously. 2 raised to 64 minus 1, it goes into trillions. You can manage all those in one operation, big numbers. And it is one more importance. There is something like, for example, if you have data which is stored, like when you have a computer, you have stored your data in the hard disk, right? In the memory disk or in the RAM. Now, how do you know where you have kept your data? How do you know when you type, okay, take this data, click this last score? How does it know to go and pick from where? You think it is a store. You're keeping things at different places. But you remember where you have kept what. The person who was working in the store, if one day he does not come, you are gone. Right? Otherwise, he should have had a written system. So what they use in stores, you know? To know which is kept where?
They mark
Yeah,
the regions in a
yeah,
paper.
they will have some number system. For each rack will have some numbers. And they will write it. Similarly, in the computer memory, you have numbering system. Okay? But then how many digits you have in your system, like in your address. This is called addressing. So to find out an address, like how many addresses you can manage. See, if you have a 4-bit address bus, you can have only 15 addresses, because you can represent only maximum number you can represent with 4 bits is 15. So you can have only 15 address locations if your address bit is 4 bits. Otherwise, you should need some other system. So your number of address bits, the bus, what you call as bus. Now, if when that is bigger, you can have larger memory, larger address. Otherwise, you will again segregate your memory into something as A, B, C, D, E, F, and each A you have 15 location, B 15 location. You had very complex systems before. So now, if you have 16-bit, 32-bit, 64-bit buses, address buses, you can manage that many bit addressing. Are you able to understand this? Yeah?
Yes, sir.
Okay. Now, find what is the value, decimal value of this. Take pen, paper, calculate,
17.
put it. Savinas is told 17. I'm waiting for others.
17.
17, 2 people.
9.
So Avinash has changed his mind. So don't trust Avinash, okay? He will tell 17, then you tell 17, then he will change 9. So now you tell 9, he will tell 15. First of all, you tell me, how are you doing it? Now Sam has told 17.
Give place value to each digit. First one 1, then 2, then 4, then 8.
Yeah, so
First,
for
I misunderstood the value. 3 zeros between.
yeah, okay. So for each one below that, you should put the place value below this. This is ones, this is twos, this is fours, this is eights. Right? That's why all of you got it wrong. You see? Go back here. This is ones, this is twos, this is fours, this is eights, this is 16s.
Sir,
Yes.
so it will be 1 into 2 raised to the power 0, then 0 into 2 raised to the power 1,
Yes.
plus 0 into 2 raised to the power 2,
Yes.
and 1 into 2 raised to the power 3.
Yes.
Okay, sir.
So what is the value? He is
So
perfectly.
9.
That is 9. This is ones, this is twos, this is fours, this is eights, this is 16s, this is 32s. Do all of you get it?
Yes, sir.
Yes, sir.
Okay, find this out. Everyone has got 51. See 51, let us see. This is 1 plus 2, 3. This is 0. This is fours. This is eights. This is 16s. This is 32s. 32 plus 16. 48 plus 2, 50 plus 1, 51. So all of you get it? All of you understand
Yes,
this? Okay. So now we slowly tighten the screw. So this is your assignment for the day. Okay. So now you understand this, right? If you have 1, 2, 3, 4, 5, 6 digits, the biggest number you can represent is 32 plus 16, 48, plus 8, 56, plus 4, 60, plus 2, 62, plus 1, 63. Right? So now you go and read evolution of microprocessors in terms of, not in terms of the computing side of it, that is on another class, but in terms of addressing. Like I told, if you have some bus of x digits, how many addresses you can manage. That is pure binary mathematics. And processing capability. Now you understand, right? If you're RAM, so you know what is RAM, right? So what RAM does, RAM takes data from your hard disk and does the processing. So if RAM is where it is happening, if in the processor, if you do not have the capability to deal large numbers, if you use a 16-bit processor, the largest number you can deal, largest decimal you can deal is 2 raised to 16 minus 1. So now with this, you go and read evolution of microprocessors in terms of capability of processing operation. Also read a bit on addressing. Addressing means from the processor, how you go and keep the data in the RAM or in the hard disk. Where then you will understand this binary business, where is it coming. You get it? Okay, now don't cut and paste from wiki and put it. I don't, even if you don't want to submit assignment, it is fine. Don't waste time. Point is you to understand. Whatever you understand, you write it in your language, even if it is 4 sentences, 5 sentences, tricky points. If one person has already answered, you don't bother answering that. See, it is to collectively learn. You go and search some points which others have not found out. Then you put that. So that if 5 people put 5 different points, we will learn something. Right. So this is your assignment. Now we tighten the screw. Okay. We get into the decimal side. See, binary also has decimal, right? Binary has decimal means what? If the decimal number is 10.56, 10 we understood how to represent. 10 for binary, now we know 8 and 2. If it is 11, 8, 2 and 1. So now we understood how to represent. But if it is 10.53, this 0.53 also we have to represent in binary, right? Yeah. So now that is not tricky, but just focus, okay? Just concentrate. Listen carefully. Not complex, but listen carefully. See, now here, what are the value? Value is very straightforward. Value of 1 is 2 raised to minus 1, it is 1 by 2. 0, 2 raised to minus 2, 1 by 4. 0, 2 raised to minus 3, 1 by 8. 1, 2 raised to minus 4, 1 by 16. So far clear? So far clear?
Yes, sir.
Okay. So how do we calculate the value of this? Exactly like how you did for the other side of it. 1 into 1 by 2 plus 0 into 1 by 4 plus 0 into 1 by 8 plus 1 into 1 by 16. Is it not? See, what you now you tell me why you add more number of decimal points in the decimal system itself. If you write 10.5, 6, 7, 8, 9, 10, 11, sorry, not 11, 11 will not come. Why you increase the number of points after decimal for what? What is the difference between, you see the entire humanity, one of the biggest chunk of their time went for calculating accurate value of pi. Why? So they had calculated value of pi to 3 decimal, 4 decimal, but if you calculate pi with the value of 3 decimal, if you apply it for the earth size, you will fall wrong by 5 kilometers. You can't use it for GPS to send a missile. So when you have large numbers, if you increase the decimal size, what will happen?
Get accurate values.
To get accurate value, to improve accuracy. Right? Have you seen 100-meter running and all? These people will come and run. So can you tell, okay, this person has completed 100 meters in 9 seconds. Other person 9 seconds. This person 9. This person 9. Can you decide who is winner? This person 9.5. This person 9.5. You know for how many seconds PT Usha lost a bronze medal in Olympics? So I think it was 1/100th of a second or 1,000th of a second. Right? So this so that short distance, you see their timings. Normally they will tell 9.72 seconds or 10.58, and then sometimes two people will be 10.58. Then you have to tell 10.583 this person, 10.58 one other person. So if you want to get accuracy, further accuracy, when you get into things like electrons mass, or you take into some quarks mass or charge, you have to get into some accuracy of some 25 decimals, because that one minor thing will change. You remember that Rohin was taking that class, he told you about that hadron collider experiment. You see where did they detect that Higgs boson? So you see, they see that charge, and that Higgs boson itself stays for some 10 raised to minus 22 seconds or something like that. That means that much small time is what it stays, and that time one click, it is in some micro kind of a charge difference, and with that measurement is what you detect a particle, and with that detection is how you get an idea of the universe. You understand? So we can apply Avinash's principle, like sir, who will ask 1 by 1.5 over roti, forget about it, sir, you know. You know, we can't get into that. We have to get into that accurate depiction to the extent possible. Am I making sense?
Yes.
Yes, sir.
Yeah. So the more number of decimals means more accuracy, right? So the more number of decimals after this means more accuracy. So actually speaking, if you tell a number like 10.538, what does it mean? You know that number is between 10 and 11. That is why you tell 10 point. The moment you tell 10 point means it is up, more than 10, less than 11. But you want to now determine between 10 and 11 where. So you tell 10.5. Okay, that means it is exactly in the center. Is it exactly at the center? Not really. 10.58. That means between 10.5 and 10.6, it is 10.58. So now if you tell, no, is it exactly 10.58? Not really. 10.586. That means between 10.58 and 10.59, it is in between. So like that, you remember in the first class we told 1 by 10, 1 by 100, 1 by 1000, 1 by 10,000. If you further go into the microscopic view, the accuracy of your decimal will increase. You understand?
Yes, sir.
Now listen carefully. Let us make sense of decimal after this decimal business in binary. Okay, listen carefully. Now first you find out this value. That is very simple. That is not a big deal. This is 1 into 1 by 2 plus 0 into 1 by 4 plus 0 into 1 by 8 plus 1 into 1 by 60. That is what is written. That is not complex. That is simple algebra. Yeah. Now you tell me, how do you add 1 by 2 plus 0 plus 0 plus 1 by 16 based on
8 by 16 plus 1 by 16.
Yeah. See, that is what we learned in yesterday's class, right? You have learned in much lower classes also. This 1 by 2 and 1 by 16 you can't add. So you have to bring this 2 to 16. So you will write it as 8 by 16 plus 1 by 16. You get 9 by 16. This is simple algebra, you know, right? But now let us try to figuratively see what does this mean. Okay. Now listen carefully. This you will learn. This you may not learn in school. So listen carefully here. Assume this is 0 and this is 1. And we are trying to find out this value, where does it fall? Okay. So between this and this, so let us assume we are trying to represent 7 point something. Then this is between 7 and 8. Assume we are trying to find out 151 point something. So we know the value is between 151 and 152. Then this is 151. This is 152. We are trying to find out between that, where is this falling? So this is exactly the representation of a normal decimal. Like for example, you tell 7.53. 7 we know how to convert. The 0.53 we want to convert. So between 7 and 8 we know. So assume this is 7, this is 8. Between that, where does it fall? We know it is 0.53 where it falls, but how to represent it in binary is the question. Okay. So now let us come to that. Okay. Now let us assume this is 0 and 1. So this is 0 point something, let us assume. So this is 1. First division is what? First division is 1 by 2. 1 by 2 means what? Normally, if this is 0 and 1 in our decimal system, how many points we divide this into? In the decimal system, let us assume this is 7 and this is 8. Okay, 7.5 or 7.6. How do we mark?
Divided into 10.
Divided to 10 pieces. Why? Because 1 by 10. Ours is 10 by system. If it is 60 by system, you divide into 60. Right? In 2 by system, you have only two stuff, 0 and 1. So you can only divide into 2. This is 0, this is 1. You understand? This is Argentina, this is Brazil. Nothing else. Right? This is Babuti, this is Maulal. Okay? This is 0, there is nothing else. No other stuff. 0 and 1. That is 1 by 2. Now what are we telling? Value of this is 1. So that means this is here or here. The number falls in the first half or second half.
First half.
No, this is 0. This is 1. See, you can divide this into, so let us assume this is 0, this is 1. Now, after the decimal, this is some decimal number is what is written in binary. We are trying to understand what it is. So 0 means it starts from here. It has not moved from here. 1 means what? 1 means 0.5 to 1 comes to 1. 0 to 0.5 is 0. In decimal, you have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Because that is decimal. You can divide it into 10. That whatever you are divided into 10, you have to manage with 2 divisions. So what you will do? Half, you make it 0. Rest half, you make it 1. So if this is 0 and 1, this is what? This is 0.5, right? So 0 to 0.5 is 0. 0.5 to 1 is 1. All of you get it?
Yes, sir.
Others? Others? Everyone?
Yes, sir.
Yes, sir.
This is important, okay? I'm spending more time here because this is important. See, now you see, what does it mean? Now we know this figure is between 0.5 and 1. Now we want more accuracy. Ye dil mange more. We want more accuracy. So we take the next one. Next one is what? 1 by 4. 1 by 4 means what? Just think of our old example. we are dividing this whole. Now we divide it into 2 pieces. Now we divide into 2 more. That means the whole division becomes 4 pieces. Like this one more here also. We are not writing here because now we know our values here. Right? So what is the value of this one now? What would be this point?
Till then 0.
Yeah, but what
Yeah,
is this? What
0.
is this point? If this is 0 and if this is 1, then this is 0.5. And then what is this value?
0.75.
This is 0.75. So what did we do? We have divided the system to 2 times. Now we are further dividing. In decimal, what we did? Between 0.5 and 0.6, we divided to 10 times again. That is 1 by 100. Or between 0.7 and 0.8, we divided to 10 more times. That became 1 by 100 each point. But here, we can only divide into 1 or 0 because we have only 2 numbers in the binary system. So we understood that the number is somewhere here. Now I can only tell 0 or 1. So 0.5 to 0.75 is 0. 0.75 to 1 is 1. What is my value? My value is 0. That means it is here. So now we know the values between 0.5 and 0.75. We want further accuracy. So this is what will be the value? This one? So be 0.625. Between 0.5 and 0.75 will be 0.625. Again it is 0. So that means it is here. Further divide. So it is in the center of this one. This is 0, this is 1. So now we know our value is somewhere here. Okay, just look into this again. Then I will explain once again. With that, we'll stop. Assume this is 0 and this is 1. Only thing we can do is to use either 0 or 1. Between 0 and 1, where is this number we want to find out? If it was decimal system, we would have divided it to 1, 2, 3, 4, 5, 6, 7, 8, 9. So if this number was 10.72, we will take 10, we will take 11. Between 10 and 11, we will divide it to 10 pieces, we will mark 0.7. But here we can't do that. We have only 2 numbers. It represents everything with 0 or 1. So we divide this into 2. So what is this value then? So this value is 0.5. This is half of 0 and 1. And we are telling that value is 1. 1 means what? This is 0. This is 1. So if we get this value is 1 means our point lies somewhere between these 2 points. So now we want to find out with more accuracy. So we divide this one more time. That is, again, this is 0, this is 1. So this value is 0.75. But here it is 0. So that means our value lies here. We divide it further. So this is 0 and this is 1 now. Again it is 0. We further divide. So like this we go. If you divide more, you will get the most accurate point. So with the first digit, we will know approximately which half it falls on. With the second digit, our accuracy improves to 0.25. With the third digit, our accuracy improves to 0.125. Just like in our decimal system, if you tell 10.5, we know between 10 and 11, it is at the center. If you tell 10.57, we tell between 10.5 and 10.6, it is where it is lying. So with each decimal, we are improving the accuracy by 1 by 10, 1 by 100, 1 by 1000, 1 by 10,000. Here we are improving the accuracy. With the first decimal, we are improving the accuracy by 0.5. Without this decimal, we would have not known whether it is here or here. With this first decimal, we improved the accuracy by 0.5. We know it here. The second decimal, we are improving by 1 by 4, that is 0.25. With the third decimal, 1 by 8, that is, 1.125. With the fourth one, 1 by 16. So with each decimal, you are improving the accuracy by this much. Do you all get this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so I completed actually very less part today. I will give you a couple of works for the home. We have next class only on Monday, but go and do this. This is important. You may not learn this in the regular existing curriculum. That because of that you may not get an idea about these things, like why this we are doing binary this way and all. So after this, in the next class, what we will learn is how do we convert. Like now we figuratively understood. After decimal means how it comes. Figuratively, we understood if we get a binary value, how to get the decimal from that. Now, in the next class, we will get into one more level deep. We'll tell that if we get a decimal number, 15.537, how to convert it to binary. So we will learn it in two parts. One, what is the technique used, which you may learn in +2. Then we will learn why the technique. To learn why the technique, this understanding is important. So we are ripping apart binary, numbers, fractions, right?